Okay, question 5. Consider the two statements R being k is an integer multiple of pi, and S. So when you go from the integral of 0 to k of sine 2x dx is 0. Which of the following statements is true? Okay, so, well, because we're dealing with integration, right? So why don't we draw the graph first? So what do we have? Sine 2x, right? So we draw a sine graph first, because it's sine 2x, so the x-axis is slightly changed. So this is 0, this would be 90 degrees, yeah? Pi on 2, I suppose, and this will be pi. Yeah, so the it is sort of a narrower wave in some way. Yeah? It is more frequent. Okay, so negative pi on 2 and this negative pi. Okay, so the integration starts from 0. So what could k be? Let's have a think. What could k be? Well, k could be 0 itself, yeah, because if you're going from 0 to 0, then it doesn't matter what the function is. That's okay. Or you could go from 0 to pi, right? Because the sine curve is perfectly symmetrical. So the area on top is definitely going to cancel with the area below. Definitely. Yeah. So that's also okay. And then the curve continues, right? The curve repeats itself. So basically you can also choose 2 pi, right? Because this area here on top is going to cancel with the one below it again. Yeah. So basically if you choose any integer multiple of pi, then yes, the integral will be 0, right? The integral will be 0. Okay, so now we have R implies S. All right, so R implies S, that means that R is sufficient for S. Yeah, R is sufficient for S because R implies S. Okay, now we check in the other direction. Does S imply R? Have a think. So if the integral is 0, does that mean that k must be an integer multiple of pi? Oh, I think so as well, yeah, because, you know, you don't have many picks. I mean, the graph is obvious enough, I think, yeah. So S also implies R, so no doubt there. So R is necessary for S then. I can't spell. All right, so that's what it means, yeah. So you got to make sure you know which direction of the implies means sufficient or necessary, yeah. So if R implies S, that means that R is sufficient for S, yeah. Make sure you know the direction. This is the, you know, if R, then S, right? This is what it means. That's the sufficient bit. That's the sufficient bit. Yeah. Okay. How about down here? If S, then R. All right, so S is sufficient for R. Yeah, if S is sufficient for R, that means that R is necessary for S. Yeah, if S is sufficient for R, R is necessary for S. So you see the relationship between these things. Yeah, they could switch rows in some way. All right, so final answer. They both imply each other, so answer would be A. Yeah, R is necessary and sufficient for S.